very gross oversimplification.
No, I didn't say 2 miles per year. No, I didn't say 2 miles per year. ISS is 100 yards long, 50 yards wide, give or take. Okay, it's three to 5 times the size of Hubble. Okay, so you have a larger mass, traveling at somewhat maybe a comparable speed. It's at lower altitude, so yes, you're going to have more drag. Hubble's at 100 supposed to be 100 miles above that, so yes, you're going to have less atmosphere, but a little bit more. You're still going to have the atmospheric drag because neither vehicle is in free space, a vacuum.
Right.
Neither vehicle.
And also, the Hubble orbit was raised during the servicing two of the servicing missions.
Yeah. You're right. You're right. I agree with you on that because I looked at the servicing missions, and it seems as though each servicing mission, Hubble dropped down based on its 15 orbits a day. If it's behaving the same way the ISS is, losing about a mile and a half to 2 miles every 5 minutes in an elliptical fashion, if Hubble's doing the same thing, that means that the STS servicing missions were able to get within a specific distance of it at a specific time to capture it, and then once they service it, they basically jettison it back up to where it should have been, which is around 330, 340 miles. But then after 2008, the last servicing mission, we're looking at 8 years. So again, you factor in from 2008 to now, within this year, Hubble's going to be within 10 to 20 miles of ISS. That's mathematics, sir. That's the mathematics that you and I've learned. Give or take. I don't have a supercomputer, so I can't do the exact numbers, but the rough calculations tell me that Hubble could be within visual eyesight view without a telescope, without binoculars. You'd be able to have literally line of sight from ISS to take maybe a Canon 100mm, 300mm camera, flip around backwards and take a photo of it when it passes over the ISS.
Well, I do not know what the ISS current altitude is.
Well, I think the current altitude of ISS should be somewhere, because ESA actually listed. And again, I mean, I had asked this question of why isn't, HST in this international database. I know someone at NASA is submitting the application for all other STS missions. Why didn't someone decide to submit the most important piece of technology ever to exist to mankind, put it in the international database? No other country is ever going to launch something that big, especially a telescope. Right now, the ISS is at, according to this data, it says the ISS is at 251.77 miles, 76. It's dropping right now. And its velocity is 17,166 miles. Longitude 153.883, actually 154. Latitude is 39.517. That's where ISS is right now. Of course, they don't have there's no similar database online to do the same thing for Hubble. And that's understandable. But
but there is.
Is there a website for same as ISS?
Well, I don't know what you're using for ISS.
Well, I'm using ISS Tracker. ISStracker.com.
Okay.
And ESA actually listed as well. European Space Agency. Yeah, I'm using ISStracker.com. This is real-time data. Supposedly real-time data.
Mm-hmm. Well, there's plenty of satellite tracking apps that have a large database.
Yeah. I have about 20 of them in my repertoire that I can check. Can't check them simultaneously, but I go after the ones that are reliable because I've found a few sites where they actually try to manipulate the data, but these are third parties who have no affiliation to the space agency. So ISS Tracker actually uses the data right off of the European Space Agency.
Okay. Well, there's certainly similar ones for Hubble. I mean, you can get Hubble's real-time position. Yeah.
Yeah, and again, I don't want to waste a lot of your time, Mike. It concerned me. I'm going to be honest with you. It really concerned me that HST was not in an international database, but the servicing missions are.
Mm-hmm.
So why would you put all the servicing missions, but you wouldn't put the primary mission to even put the vehicle where it is? I got another theory too on atmospheric drag that I'm actually playing around with. I'm starting to look deeper into superfluid helium-4, and it's just one of those type of things that I've seen it do some really strange things in a laboratory setting, and some other colleagues of mine at the university were actually entertaining the idea, the possibility, theoretically, that the upper atmospheres beyond HST could be superfluid helium. It's zero viscosity, but what we're trying to ascertain is, could it be actually a combination of what CERN and NASA are considering to be dark matter or dark fluid, which is absorbing 99.96% of all visible light. And that's why when you're looking at these videos of HST being serviced, you see absolutely no other light. Absolutely none. And it has nothing to do with the resolution of the camera and what mode the camera may be in to capture that type of light. If you've got billions of stars out into free space, then, or even within atmosphere, even a cluster should be generating some sort of light, and you see absolutely nothing. And the only way that that's possible is if actually what you're looking at when you're up in altitude in space, which is beyond 328,000 feet, is you're looking at dark fluid and superfluid helium, because the only way a vehicle the size of a school bus or the size of a football field could be in geosync orbit performing those operations would be in a helium environment, a liquid fluid helium environment where the temperature is almost absolute zero. You can do it in a laboratory. That may be what's up above us.
And what kind of densities are you talking about?
Well, the densities are already stated with helium-4. Helium-4 is I'm still trying, everyone's trying to wrap their head around how could it actually still stay a liquid at absolute zero. See, no one can answer that. And I've looked at every university paper I could possibly collect, and it can't be simulated. You can't get anything to absolute zero on Earth. We don't have the technical capability to do it. And you can't do it on the ISS because the ISS can't, you're in a microgravity environment. There's atmosphere. You can't create it in a vacuum either, because there is no such thing as a complete vacuum. And the reason why I say you can't do it in a vacuum is because the Glenn Research Center has the largest vacuum chamber in the world, but it's a contained environment. Meaning that you have walls, you have limits. You can't create a vacuum chamber large enough to duplicate the potential experiment to get close enough, because if you did, you'd probably suck half of NASA into that vacuum chamber if there was some sort of malfunction. It would be a massive implosion. And you can't contain superfluid helium even at close to absolute zero, for the simple fact that you have to create some sort of carbon nanotube type of container just to keep it in the container, because it wants to find its way out of what it's being contained in. And when you look at what Siri Nanosystems did in UK by creating Vanta Black, and you combine that with superfluid helium, and then you hear scientists are saying that dark matter, aka dark fluid, and you put the two together, you've got your space environment. That's the only way something the size of a football field and the size of a school bus could move around at potentially 5 times the speed of sound in a quasi-microgravity environment for as long as it is. Because what they're saying about superfluid helium is that there's these quantum vortices created, whirlpools, that are spinning at incredible speeds. And what happens is that when they release droplets of superfluid helium in this vacuum, what they witnessed and observed in a controlled experiment environment was that the droplets didn't break apart like normal water molecules would break apart. They remained together, and they formed a flattening ellipsoid egg-shaped type of form. And it started to make sense to me. Wait a minute. That's the only way these vehicles could be up there traveling at those speeds. Because if not, they'd come crashing down within years, not decades. Just some theoretical talk. I'm just throwing it out there. I'm not a physicist. I'm working on my master's in applied physics, but trying to get an understanding. And Hubble is continuing to baffle me. Right now, they're showing the Hubble at the latitude is 20. What's the elevation? The altitude is 542 kilometers.
Yeah, okay, sounds about right.
So, but it's a software database, and I can tell you here right now, as a CUDA and GPU programmer and developer, I could create the same thing in a week to mirror this, and it wouldn't need to be real. It'd literally show a picture of me in a little Superman cape, saying, "Hey, this is where I am. I got my hands on. I've got a little tether on the Hubble, and I'm following it. And look at me, And people would. But here's the thing: if I showed you that and put it together in a week, you'd be like, "Oh, that's not real," But I want you to understand, as an up-and-coming research scientist, the average person, they look at this and they're like, "Oh, well, there goes the Hubble at 542 kilometers." But you show them something they don't know. They don't have even a basic or foundation understanding of how software development, programming, and computer graphic generated images, and how you can actually program something to be in the sky that's really not there.
All right. Yeah.
So
Hollywood does it all the time.
No, I know.
Yeah.
I mean, I've actually taken advantage of you guys' software vault, where I can go online and download a lot of the software applications that's available for the technology transfer program. So, it's just one of those things to where I would like to know if it's possible, if anyone I could speak to who's responsible for submitting the information to FAI, to see if maybe there was just an oversight, or if it's a mistake, and I hate to say this, that maybe you've been sitting there for 25 years and there's what you think is up there is really not there, and it's actually the photos are being taken by Sophia, which is at 45,000 feet on a 747.
Sophia hasn't been flying nearly as long.
Well, the program, the Stratospheric Observatory program, has been in existence longer than Hubble.
But they haven't had